Hello, this is presentation 7.5. The topic is inferences for small samples. In particular, we're going to look at the student t distribution. This material is in your workbook and your textbook, chapter 7. To illustrate the notions involved, we're going to consider a tobacco manufacturer who makes the claim that the tar content of its cigarettes is significantly below 6.00 milligrams per cigarette. A human rights group challenges this, and they undertake a sampling of unequal 18 cigarettes. The results appear in this figure to the right, and we see here that the sample mean X bar is 5.88. There's the standard deviation based on n equal 18. And we're suggesting when we're looking at small samples and sigma is unknown, we look at what's called the student t distribution. It appears here in the red. You'll notice that the red curve is flatter and broader than is the normal. And you can see here that the student t appears in red, and it varies depending on your sample size. The sample size being n, the degrees of freedom is n minus 1. So this red curve changes with the sample size, and there's greater uncertainty in the red than is the blue because of the breadth involved. Now for 95% for the normal curve, the z-score is plus or minus 1.96. Now, for the student t, it's in the red, the critical values for 95% and 5% in the two tails is plus or minus 2.110, and they're slightly greater than 1.96 to denote the uncertainty in the estimates because we don't know what sigma is. We're using the sample standard deviation, Sx. Now we go to the table here, and we're going to show you where this 2.11 comes from. We're going to suggest to you that the degrees of freedom is n minus 1, which in this case is 17, and the area in the tails is 5%. The area in the right tail is 0.025, and that's what the table gives us. Coming down here then, the critical value is 2.110, and this suggests that whereas in the normal curve we have the 1.96 sigma sub x bar over n, we're saying for the student t is 2.11 times s sub x over n. This gives rise to a confidence interval. You see them coming on the screen here now. So 95% chance that this interval will capture the true population mean. This interval gives you 5.696 to 6.04, and we're asking, since that 6.00 is in this interval, this evidence suggests the tar count is not significantly below 6. And now we're going to look at yet another example. We have a random sample of 21 people in an office area. The mean systolic blood pressure 120.8, standard deviation 8.4. We want to look at a 99% confidence interval. And if you recall, the 99% confidence interval for the normal curve acknowledges a z-score plus or minus 2.575. For the t distribution and 99% confidence, the t value is 2.845. Notice it's above or greater than the z-score. Now those come from the table of the two distribution probabilities. We're saying 21 sample size, your degrees of freedom is 20, and we want 99% confidence. So the area in the two tails is 1%, the area in one tail, the right tail, 0.005. And looking at that, we see the critical value is 2.8453. And so that's where that comes from. The standard error is given by 8.4. The margin of error, coming on the screen here now, 128.8, that's your sample mean X bar, plus or minus 2.845. And this gives rise to the confidence interval 282 to 286.9. Now that's the end of presentation 7.5. We asked that you review these and go on to presentation 7.6.